Hey, fourth grade, just working on my energy here. So, yesterday we learned that energy is the ability to do work. We also learned that energy in an object is called stored energy when the object is not being moved or not using the energy. When it's just stored, like for example, me holding this basketball back, we learned that that was potential energy. Now, what happens when that basketball leaves my hand? Whether I shoot it in the hoop, whether I spin it, excuse me, I spin it around, whether I toss it to a friend, what happens to that potential energy? Well, that potential energy gets transferred from stored potential energy into energy in motion. Energy in motion, almost at the computer, energy in motion is called kinetic energy. So let's say that kinetic energy. So, kinetic energy is when that stored object is now moving, okay? That energy, that object is moving, all right? So, it could be me throwing this, it could be me tossing it, it could be me just tossing it up, it could be me throwing it around, okay? So, now we're going to explore kinetic energy a little bit more. Yesterday, with potential, we talked about a bike being up on a hill. Well, that bike has stored potential energy, okay? It's up pretty high, the person has had to pedal up high. Now, as the bike goes down the hill, it's going to use that energy that was stored and it's going to transfer it into kinetic energy, which is energy in motion. Now, depending on how fast the person pedals down, depends on how much kinetic energy is being used, okay? Also, the higher up the object is, the more kinetic energy it will have because it will have a longer way to go in motion. So when we look at this guy down here, he is using that kinetic energy and eventually it'll get less and less, okay? Now, kinetic energy can also just simply be a throwing of a baseball. So this person holding the ball, that's potential energy. As soon as it goes in motion, that's kinetic energy, okay? So let's do an action with this. So potential energy, we stand, it is stored. Say it with me. Potential energy, stored energy. Kinetic energy, energy in motion. So move around. Repeat after me. Potential energy, stored. Kinetic energy, energy in motion. All right, let's dig a little bit deeper into this, okay? So, not only is kinetic energy dependent on a lot of different things, but it's also dependent on something called velocity. And so, velocity is the faster an object is, that's the more energy it's going to have. So, that's when I talked about here. The faster this person's going, the more kinetic energy, the more velocity it has, the more kinetic energy it has, okay? So, in my hand right now, if it's going slow, that's the less kinetic energy. When I spin it fast, that's more kinetic energy, okay? Also, an important thing to remember with energy is the heavier an object is, the more energy it's going to have. Okay, so think about bowling. If you hold a smaller ball or a lighter ball, it's going to have less energy than a bigger weighted ball. Okay, so if I take this one versus a bowling ball, which one's going to be faster? Okay, so the weight depends on the kinetic energy depends on the weight as well. Okay, so here's something I want you to think about. If you had a plastic bat or you had a metal bat and you were up to bat, which one would have more kinetic energy? Which one would be able to hit that ball further? Which one would have more stored energy based on its weight? Again, that's a plastic versus a metal one. Think about that. Which one would have more energy than that? All right, so let's review our two different types of energy. We have potential, it's stored. We have kinetic, and that's energy in motion. And the energy is not really changing, it's just being used differently. So that potential energy is just changing into a kinetic energy. So after you read that paragraph, you are going to answer some questions. So, as soon as that bike starts going down that hill, that stored energy becomes what type? Okay, read through those choices. And energy in motion is called what? We talked about that. What's that called when it's in motion? And the faster an object goes, is it going to have more energy or less energy? Think about that biker going down that hill. Okay, if they're pedaling, obviously they're going to go faster. So is that going to be more energy or less? Think about that. And then, lastly, I want you to think about these things. In the above passage, it says the mass an object has, the more kinetic energy it will have. So, what does that mean? What does mass mean? How can you explain that? So, the more mass it has, think about that bowling ball versus the basketball example I kind of talked about. What does that mean, mass? Okay. And then we talked a little bit about this too. The passage above says a metal bat will have more kinetic energy. Well, why do you think it has more? Why is that? If that's the choice we are going with, why does it have more kinetic energy? Then you are going to watch this video below, and I want you to find two new other examples of kinetic energy. Okay, I want them from the video. So give me two examples from the video of ways that an object is using kinetic energy. Okay. Then last week we did an ABC chart where you had to look around your house. I did the example of a light bulb. Okay. So what I want you to do is pick one of those items that you put on your list and then tell me how is it using potential and kinetic energy. So for example, I put on mine, when I looked around my classroom, I put a chair. So a chair uses potential energy when it is just sitting there. Okay. When it's just waiting in the classroom, it's just sitting there. The kinetic energy and motion, when that chair starts getting rocked back and forth. I have some kids that can't sit still on their desk. So when the chair gets rocked back and forth, that potential energy that was stored in that chair is now becoming kinetic energy. Okay. Because it's moving, the kid's rocking back and forth. And I get that sitting in a desk is hard sometimes. So look around. If you don't remember what items you put, look around your classroom, look around your home. What is an item that you can explain the kinetic and potential energy? Another example would be my basketball. In my hand, it's the potential energy, but the instant I start spinning it around, it becomes kinetic energy. All right. As you move forward in this, take a look around the world around you, and I want you to see what does energy do to all the items around us? How is kinetic and potential energy in every single item? Pretty much in the whole world. So, yeah, that ABC chart, I hope you realize that pretty much anything that you listed has energy because potential energy is stored in it. And then once you start moving that object, well, it has kinetic energy. So, that ABC chart was kind of a trick question because, well, everything has energy.